stem and leaf plots and using a stem and leaf plot to display data. So let's start with just the definition of a stem and leaf plot. Is that it uses digits of the data. So like the tens place, the ones place, bless you. It uses the digits of the data to organize values in the data set. So with a stem and leaf plot, we break the data, divide data into a stem which is going to be the digits on the left. Okay, the digit or digits on the left. So divide that into a stem and, bless you, a leaf, which will be the digits to the right. And the reason they're helpful is that stem and leaf plots show how the data is distributed. So kind of like a dot plot, like that was also what a dot plot showed, is if you drew a dot plot, you could see kind of how the data was distributed. You could see if anything was really far to the left or right. You could see if a lot of it was around a certain set of values. A stem and leaf plot kind of shows the same thing. Do our example. Let's do, to make a stem and leaf plot. To make a stem and leaf plot, here's what we will do. So you'll be given data, just like we did with mean, median, mode. It's like it gives you a set of data. We are going to put the data in order. So just like we did with, especially when we were finding the median in the range, we had to put it in order from least to greatest. So put in order from least to greatest. Once we do that, then we need to decide what we want our stem to be and what we want our leaves to be based on the values of the data we have. So if we have all, digits that are 1 and 2 digits, so maybe from like 5 to 27 or something, maybe we want our stem to be the tens place and our leaf to be the ones place or something like that. So you need to decide how you're going to break up your stem and leaf. You can only have a stem and a leaf, so there isn't room for 3. So if you have 3-digit numbers, you have to figure out how you want to organize that data. Mostly we'll have 2-digit numbers. So choose what digits. Yes. Choose the digits will be the stems and the leaves. Bless you. Okay, then we're going to draw your plot. It always looks like this. We'll have a straight line that's horizontal and then a vertical line. Okay, to the left will go your numbers that are your stem. And then on the right will go your numbers that are your leaf numbers. And then we fill that in.
Looks like a crane.
Stems go on the left, leaves go on the right. Okay? All right, so let's do one. I'm going to pause this for a second. All right, so we are going to, this example, this set of data, It says it's the length of different phone calls. So the minutes are showing the length of different phone calls over the course of these days. Our job, we are told to make a stem and leaf plot of the lengths of these phone calls. So let's use our steps. Step 1 is to do what? So in order, our lowest number is 2. And then 3. 2, 3, 5, 6. Bless you. 10. 14. 18. Okay, 23. 23. 30. 36. And finally, 55. So there's our data in order. Okay. Once we have it in order, we can see sort of the numbers of digits and sort of the range of the digits and the values that we need to put in a stem and leaf plot. If we're going to do this, what do you think our stem should be? What place, what digits place, what place value should be our stem? What do you think? Nope, the dates aren't going to be part of this. We're only talking about the minutes. What do you think the stem should be? Actually, I think I was doing the stem in orange. The tens place or the ones place? Hudson?
The tens place.
Good. Let's do the stem, our tens place. And then our leaf would be which digit, which place value? Liam? The ones place. This is a lot of times how stem and leaf plots are set up. Tens and ones, okay? So now we're going to look at each value. We'll set up our stem and leaf. Okay, and then over here on the left will be our stem, and to the right will be our leaf. So let's start with our first value, 2. What's the stem of 2? Luke? What's the stem of 2? What are we going to put to the left? Shh, Eddie. Not 20. Don't yell it out. Just put your hand up. Sam, what's the stem? 0. We have 0 tens. And what is our leaf? 2. All right, so we've done that one. What about with 3? What's our stem of 3? Modibo? 0. So 3 is going to go in this same column. Everything that has a stem of 0 will go on this same row. So we would put our 3 here. Same with 5. It has a stem of 0 and a leaf of 5. So everything that has the same stem will go on the same row. All right? So our first set, our first row, all the numbers that have a stem of 0 are 2, 3, 5, and 6. Okay? Then we come to 10. What is our stem in the number 10, Hudson? 1. So we start a new row of numbers that now have a stem of 1. What is our leaf of 10? Dylan? 0. So that goes on our leaf. 14 also has a stem of 1. What is its leaf? 4. Do you see how this works?
Yeah.
Okay, 18 has a stem of 1 and a leaf of 8. What happens when we get to 23? What happens when we get to 23, Tate?
You just do 2 instead.
Good. New stem of 2, leaf of 3.
If you do another 3?
We do another 3 because we have 2 with a stem of 2 and a leaf of 3. We have 2 number 23s. We have to put that twice.
I understand so much.
All right, then we get to 30. Our stem is 3. Our leaf is good. 36, our stem is 3. Our leaf is 6. Okay, we are going to put a placeholder 4 here. But there are no values that yes, if we leave it blank, there's no 40, there's no 41, there's no, but it shows us the distribution of the data that there is a gap at that place. Okay? All right, and then finally, stem of 5, leaf of 5. All right? This stem and leaf plot shows us the quiz scores on a certain quiz. So how many students earned points? This is an important part of a stem and leaf plot down here. The key tells you what the stem represents and what the leaf represents. In this case, we're not talking about tens place and ones place. In this case, Hudson?
The ones place and the hundreds place.
Close, tenths place, right? The stem is representing a whole number. This line is basically representing a decimal, right? They told us that here. Because if our stem was 9 and our leaf was 2, they're saying that represents 9.2. Okay, so we're talking about points here and decimals rather than tens and ones. All right. Here's what it says. A couple of questions about this stem and leaf plot that we're going to be asked. Letter A says, how many students scored less than 8 points? How many students scored less than 8 points? Kennedy, what do you think?
5.
5. How did you find that?
By counting all the numbers beside the 76.
Very good. So we had one student score 6.6, 7.0, 7.5, 7.7, 7.8. So a total of 5 scored less than 8 points. And we can use our stem and leaf plot to see that. Good. What about letter B? How many students scored at least 9 points? At least 9 points. Modiba, what do you think?
I think
3. At least 9. Edna, what do you think?
4.
4. Why do you think 4?
Because you'd count the 100 as well.
Yes, right? So these are 3. This is at least 9. 9 or greater. At least means 9 or greater. 10.0 is also 9 or greater, right? So a total of 4 students got at least 9, which means 9 or greater. Good. All right, last one. Letter C asks, oh gosh, how, oh my gosh, my little pen isn't working. How is the data distributed? Because that's what a stem and leaf plot shows us, how the data is distributed. So we're going to sort of describe what this data looks like. So like, how could you describe, based on this stem and leaf plot, what do you notice? What do you notice? Well, what do you think?
A lot of people got 8.
Very good.
A lot.
Okay, so can you see that a lot of people scored in the 8 range?
Yeah.
Right? 1 scored in the 6, 1 scored in the 10, and a few scored in the 7 and 9 places, but most of the scores are in the middle around 8, right? So it shows us that distribution really easily just by looking at the graph. The stem and leaf plot shows the heights of several houseplants. Use the data to answer the question, what is the typical height of a houseplant? What kind of a question would we call this? Statistical, right? So this is tying back into that last chapter. Is there one specific height? No, but we can use these measures to find it. Now, the key here is being able to read the stem and leaf plot to be able to find what they ask us for. Mean, median, and mode. Let's start with the easy ones. Very good. Check your key always. Okay, in this one, our key is a tens place and a ones place. So a stem of 1 and a leaf of 5 is 15. The mode is the number that appears most often. Miles, what is it?
11.
Good. Okay, we can see we have 3 ones in our leaf with a stem of 1. So our mode appears most often is 11. Now the nice thing about a stem and leaf plot is they are arranged for you in order from least to greatest, so it makes it a little easier to find the median. You don't have to reorder them. So we can do our median practice or technique and get rid of the highest and lowest values. What's our median? 11 as well.
That's the best number.
11. And then to find the mean, we are going to need to do our addition. So we have to use what we know about stem and leaf plots. We're going to add all these together. 1 plus 2 plus 4 plus 5 plus 6 plus 8 plus 9. And then we need to remember the stems on the second part, right? Plus 11 plus 11 plus 12 plus 15. Our new stem plus 22 plus 32. 62. And we need to divide by how many numbers total are in our stem and leaf plot? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Very good, 15. So we will divide by 15 to get our mean, which equals 10.8. All right. Erase those. So our mean, median, and mode are all pretty close together, 11, 11, and 10.8, which is almost 11. So, and we can see too that our data is distributed between basically 10 and 11. So those all kind of make sense. What would you say? What is the height of a typical house plant? We had a little trouble with this on the quiz yesterday. People were like, between like 10 and 11. Give me a value. What is the height? And justify it with statistics. What would you say, Hudson? 11. Why?
Because the mode and the median both.
Good. So that would be a good argument. We could say 11 because both the mode and the median are 11. So it's a good measurement. And the mean is very close to 11. Good. So I would say 11 would be a good answer with good justification.